Right now, somewhere out there, two black holes are falling toward each other at 150 million miles per hour. And they've been doing it for longer than Earth has existed. Not drifting, not coasting, falling. Each one is the collapsed corpse of a star so massive it couldn't hold itself together anymore. Each one has gravity so extreme that light, the fastest thing in the universe, goes in and never comes back out. And somehow, they found each other. Here's the thing. They've been locked in an orbit that's been tightening for millions of years. Every single revolution, they bleed off a little more energy. Every loop, they get closer. The gap shrinks, the speed climbs, the orbit tightens further. It's a death spiral. And it only ends one way. And when they finally merge, they don't just crash into each other. They reshape space-time itself. Before we get to the collision, you need to actually feel what these things are. Because black hole has become a comfortable word. It shouldn't be. Start with a star. Not our sun, but something 30 times more massive. It burns for millions of years, fusing hydrogen into helium, helium into carbon, carbon all the way up to iron. And then it hits iron and everything stops because iron absorbs energy instead of releasing it. The core collapses in under a second. The outer layers come crashing inward at 70,000 kilometers per second, bounce off the core, and explode outward in a supernova bright enough to outshine its entire galaxy for weeks. What's left at the center is a singularity, a point of infinite density, zero volume, where every equation we've ever written breaks down completely. Surrounding that singularity is the event horizon, not a surface, not a wall, a boundary, the point of no return, where you'd need to move faster than light just to escape. Cross it and you're not dead. You're gone, causally cut off from the rest of the universe, forever. A stellar mass black hole might have an event horizon just 30 kilometers across. 30 kilometers. You could drive that in 20 minutes on the highway, but the gravity at that edge is so extreme that time itself runs slower there than it does right here, where you're sitting. And somewhere out there, two of these things are orbiting each other right now. But here's what nobody tells you about what happens before they collide. They don't just fall straight at each other. That would be too quick, too clean. When two massive objects orbit each other, they radiate energy as gravitational waves, literal ripples in the fabric of space-time, spreading outward at the speed of light. Einstein predicted this back in 1916. For 100 years, nobody could prove it was real. Then in 2015, they did. The LIGO detector picked up a change in length smaller than 1/10,000th the diameter of a proton. That's not a typo. Read it again. A proton is already 100,000 times smaller than an atom. LIGO detected a fraction of that. The signal lasted less than a second. But that 1 second carried more information about raw, cosmic violence than anything we'd ever directly recorded. Two black holes, one 36 times the mass of our sun, one 29 times, had been spiraling toward each other for over a billion years. Their final 200 milliseconds of approach were what LIGO actually caught. In those final moments, they were moving at roughly 60% the speed of light, and they were still accelerating. This next part is the reason physicists lose sleep. In the final millisecond before merger, one single millisecond, these two black holes are releasing more energy than every star in the observable universe is putting out combined. Not nuclear energy, not heat, not light, gravitational wave energy. Pure raw distortions in space-time, radiating outward at light speed in every direction at once. Get this, the observable universe contains roughly 2 trillion galaxies. Each galaxy averages around 100 billion stars. Every single one of those stars is burning, radiating energy every second of every day. In that 1 millisecond, the merger makes all of that look like a candle in a hurricane. But here's where reality gets stranger than anything you've seen in a movie. You wouldn't feel it coming. Gravitational waves pass through matter almost completely unimpeded. Rock, steel, lead, flesh, all of it is basically transparent to gravity waves. That 2015 signal that moved our instruments by less than a proton's width, that wave passed straight through the entire Earth. passed through you, you felt nothing. You were already touched by two colliding black holes. You just didn't know it. But here's where it gets worse. Let's say you're close. Not inside, not yet, just close enough to see both event horizons. Stick with me here. The first thing you'd notice is the light. Stars that should be hidden behind the black holes are visible. Not just visible, multiplied. Gravity is bending light around the event horizons like glass lenses, creating duplicate images, arcs, perfect glowing rings. The sky looks like a shattered mirror of the real universe. It's the most beautiful thing you've ever seen. Then your skin registers something before your instruments even react. Not heat, tidal force. The side of your body closest to the nearest black hole is being pulled fractionally harder than the side facing away. The difference is small right now. It won't stay small. You're being stretched along the axis toward the black hole and compressed from the sides, like a piece of clay being pulled slowly from both ends. Physicists call this spaghettification, which honestly sounds almost gentle. It isn't, not even close. Your bones would separate at the joints before your muscles even had time to tear. The fluid in your spine would experience measurably different gravitational forces from top to bottom. Your circulatory system would drain toward whatever hemisphere is facing the singularity. And the whole time, those two black holes are completing their final orbits hundreds of times per second. And the space-time around you is oscillating, stretching, and squeezing in alternating directions as gravitational waves from the Inspiral ripple straight through your body. You are inside a wave of space-time distortion the size of a solar system, and then they merge. The moment of merger lasts less time than it takes a single photon to cross a hydrogen atom. But what it creates is the loudest event in the universe. What's left is called a Kerr black hole, a spinning singularity, rotating so fast that it physically drags space-time around with it. The region just outside the event horizon, called the ergosphere, rotates with it. Space-time itself is spinning. In that region, it's physically impossible to stay still relative to distant stars. You don't have a choice. The fabric of reality is being stirred like water circling a drain, and you rotate with it whether you want to or not. Here's the part that genuinely wrecked me when I first understood it. The 2015 merger resulted in a final black hole with a mass of 62 suns. The two that collided had a combined mass of 65 suns. 3 solar masses simply vanished, converted in 200 milliseconds into pure gravitational wave energy. 3 entire suns worth of mass gone exactly as Einstein predicted, exactly as EMC2 demands, turned into ripples of space-time that will expand forever, growing weaker but never fully stopping, spreading through the cosmos until the last star burns out and the last galaxy goes dark. Those waves are still expanding, right now as you watch this, traveling outward from a point 1.3 billion light-years away, crossing space, passing through gas clouds, dead stars, living planets, passing one day, billions of years from now, through whatever is left of Earth. Here's the part that never makes the headlines. In the far future, sure so far that the word future barely applies anymore, the universe will be dominated almost entirely by black holes. Stars will be gone, galaxies will be gone. There will just be black holes orbiting other black holes, in pairs, in clusters, falling slowly toward each other in spirals that last trillions upon trillions of years. And they will collide, again and again. Merger after merger after merger. Each one radiating gravitational waves, each one building a larger remnant. A universe that looks like nothing, but is quietly, relentlessly, violently alive in the only way it is left. Until Hawking radiation, the slow quantum evaporation that even black holes can't escape, claims even those. But here's what nobody tells you. The gravitational waves from every merger that has ever happened, every black hole collision since the universe was young, those waves are still out there, right now. They form what physicists call the gravitational wave background, a constant low-frequency hum woven directly into the structure of space-time itself. The universe is not silent, it's ringing. It has been ringing for billions of years, from collisions so violent They warp the geometry of space, and the echo of every single one of them is still propagating through the cosmos, through you, through this room, through this exact moment right now. Here's the thing that actually gets me. Every time two black holes collide, they don't just destroy each other. They communicate. They send a signal encoded in space-time across billions of light years, carrying the exact masses, the spins, the final moments of their entire existence. And we've learned to read that signal. We've learned to hear the universe scream. And what we found is that collisions aren't rare. They're not special. They're constant. The universe is absolutely full of black holes finding each other, spiraling in, merging, building structures we don't fully understand yet, maybe seeding the supermassive black holes sitting at the centers of galaxies, maybe doing something else entirely that we haven't figured out yet. And honestly, the most honest answer is we don't know what we don't know. LIGO and its sister detector Virgo have caught dozens of merger events so far. Every single detection rewrites something. Every signal carries information nobody expected. The universe has been waiting billions of years for something with ears small enough to actually hear it. We built those ears in 2015, and what they're hearing is a cosmos in constant, violent, perpetual conversation with itself. Not in light, not in sound, but in the curvature of space and time. Two black holes collided 1.3 billion years ago, before complex life existed anywhere on Earth. And the shock wave of that moment crossed the entire universe, reached us, moved through us, and told us exactly what happened. We were listening. We're still listening. And somewhere out there right now, another pair is already falling. If that's going to keep you up tonight, if you're already doing the math on what's out there, subscribe. There's a lot more where that came from. When two black holes collide, the universe rings for billions of years. Two black holes. A billion-year death spiral, and a collision that releases more